Hello, my dear students. Have you ever wondered how much air your lungs can actually hold, or what happens when you take a deep breath or blow out forcefully? Today, we will explore into the amazing world of respiratory volumes and capacities, the numbers behind your breath. With easy explanation and a helpful diagram and exam ready tips, we will make these concepts crystal clear for you. So fill up your lungs and get ready to breathe in some knowledge. Let's begin the journey into your lungs. The topic respiratory volumes and minute ventilation explains how the lungs function during normal and measured breathing. At rest, a healthy adult breathes approximately 12 times per minute, and each breath moves about 500 ml of air. This is known as the tidal volume or VT. The minute ventilation (mv) is the total volume of air breathed in and out per minute and is calculated by multiplying the respiratory rate by the tidal volume, that is 12 into 500, that is 6000 ml or 6 liter per minute. A decrease in this value may indicate respiratory problems. To measure these values, devices like spirometer or respiratometer are used, and the resulting graph is called as spirogram, where inhalation appears as an upward curve and exhalation as a downward one. The topic explains how not all of the air we breathe in is used for gas exchange and how long lung volumes vary between individuals. Of the 500 ml of tidal volume in a normal breath, only about 70%, that is 350 ml, reaches the respiratory zone, that like alveoli, where gas exchange occurs. The remaining 30% or approximately 150 ml of air stays in the conducting airways like nose, trachea, bronchi, etc., and is known as the anatomic dead space, which does not participate in gas exchange. A useful tip, that is the dead space in ml, is roughly equal to one's ideal body weight in pounds. The alveolar ventilation rate or AVR is the actual volume of air reaching the gas exchange area per minute, is calculated as 350 ml into 12 breaths per minute, that is 4200 ml per minute. This diagram illustrates the various lung volumes and lung capacities which are essential for understanding pulmonary function. It shows how normal breathing, represented by the wavy red line, consists of regular tidal volumes of 500 ml with deeper inhalations and exhalations, demonstrating inspiratory reserve volume 3100 ml in males and 1900 ml in females, and expiratory reserve volume, that is 1200 ml in males and 700 ml in females respectively. Even after maximum exhalation, a residual volume remain in the lungs at 1200 ml in males and 1100 ml in females, which cannot be expelled. The diagram also shows lung capacities formed by combining these volumes: inspiratory capacity, that is TV plus IRV, functional residual capacity, that is ERV plus RV, vital capacity, that is IRV plus TV plus ERV, and total lung capacity, that is VC plus RV, with corresponding average values for males and females. This visual aid helps in comprehending how much air the lungs can move and retain during various phases of breathing. Did you know your lungs hold clues not just about your health but even about your life and death at birth? Lung volumes change based on your gender, height, and age, being larger in males, taller people, and younger adults, and smaller in female, shorter people, and the elderly. Doctors use this value to check lung function. But here is something fascinating, that is, there is a special volume called minimal volume (mv) that stays in the lungs even after a forceful exhale. When the chest cavity is opened, some air escapes, but a very small amount stays behind. This is the minimal volume, and it plays a key medical and legal role. In fact, doctors can tell whether a newborn was stillborn or breathed after birth using the lung float lung float test. If the lung floats, the baby took a breath. If it sinks, the lung never had air. It's amazing how a tiny pocket of air can speak volumes. Ever wondered how much air your lungs can actually hold? Let's explore your lungs capacities, which are simply smart combinations of different lung volumes. When you take a normal breath and then inhale deeply, you are using your inspiratory capacity or IC, that's your tidal volume TV plus inspiratory reserve volume IRV, that is 3600 ml in males and 2400 ml in females. Now, even after a normal breathe out, your lungs still hold some air. This is your functional residual capacity made up of residual volume plus expiratory reserve volume ERV, that is 2400 ml in males, 1800 ml in females. If you combine your deepest breath in and strongest breath out, you get your vital capacity, that is about 4800 ml for males and 3100 ml for females. And finally, when you add even the leftover air, residual volume, you get the total lung capacity or TLC, the full tank your lungs can hold, a hopping 6000 ml in males and 4200 ml in females. Is not it incredible how your lungs are designed to store and move air so efficiently? I hope this class made the concepts of respiratory volumes and capacities crystal clear for you. From simple tidal breaths to maximum lung capacity, you have now seen how every volume and capacity plays a vital role in your breathing efficiency, and how doctors use these values to assess a lung health. With the help of diagrams and easy formulas, you have learned not just how we breathe, but how much we breathe. If this step-by-step breakdown helped boost your understanding, don't forget to like, share and subscribe for more such simple student-friendly lessons. Keep revising, keep practicing and always stay curious. See you in the next class. Take a deep breath and keep learning. Thank you.